This is Tech Math 2, and we're in section 4-1. And the issue is we have functions. So what makes something a function? Is that a function? So we're going to vote on it. Yes. No. Okay, how many yeses if this is a function? Okay, I see one yes. Yeah, how many no's if this is not a function? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everyone else, including the one that said yes. Of course it's a function. There's nothing wrong with this. This is a function. What makes something not a function? What makes something a function is that for every x, there's only one f of x. So at this point x, there's only one point there. That's what makes it a function. At this x over here, there's only one point there. If I had a curve that looked like this, that is not a function. Okay, that is not a function because when I come here at some x, I've got 1, 2, 3 different values for f of x. That makes it a non-function. So a function is something that has a one-to-one correspondence with the value f of x, whatever it is. So when I go and look at the if I look at the arc cosine function. Okay, so I'm going to look at the arc sine function. So I'm going to look at the arc sine function, and it does this. And that's -1. This is 1. The arc sine function would not be a function if that is exactly what it is. And it is. That's what it is. It goes on forever and ever in every direction. But what we do is we decide we're only going to let this work from 90 degrees to -90 degrees. So when we take the arc sine function, we're not dealing with every possible point. We're only saying arc sine is only defined from -90 to +90. And so in my calculator, when I get an answer, and that's what I'm going to get. I'm going to go +90, -90 answer. I'm never going to get 210 degrees out of my arc sine function, because then it would not be a function. All right. A function has a dependent variable. Dependent variable. This is English. And it has an independent variable. All right, so I got x is equal to y. X is equal to f of x. Okay, what is the dependent variable? Okay, show of hands, how many think it's x? How many think it's y? Correct. Okay, so the dependent variable is the f of x, is the y guy. The independent variable is the x guy. So I could have f of t, for example. F of t is equal to 1/2 at squared plus v naught t plus x naught. And t would be the independent variable, time f of x, and we'll change it to x of x, x of t. That would be my dependent variable. So I graph something, my independent variable goes on the x-axis. My dependent variable goes on the y-axis. So I'm going to do a graph of current versus voltage. Okay, so I've got some current down here. I got some voltage down here, some current up there. So my voltage would be my independent variable. I'm running it back and forth, and I'm calculating what my I is, and if I have a diode, it looks something like that. So I have a characteristic curve of a diode. Okay. A function will have a range, and it'll have a domain. All right, so the domain are all the values of x that are okay to use. Okay, so I got y is equal to the square root of x minus 4. What's the domain? Well, the domain would be everything that I can use. So x has to be greater than or equal to 4, because if x is less than 4, then this becomes a negative number, and I take the square root of a negative number, and it's not until chapter 14 that I can take the square root of a negative number, which I can't do yet because I'm in chapter 4. So, all right, I've got, does that make any sense? So y is equal to 1 over x minus 4. Well, the domain, I can have minus infinity, and I can go all the way up to 4, and I can be greater than 4, but I can't be 4 because I'm not allowed to divide by 0. So, okay, so that's my domain. And then I've got range. Range are all the possible values of y, the dependent variables. So I got y is equal to 1 over x minus 4. My range is going to be plus or minus infinity. Will 0 be in there?
Y can be 0.
Y can be 0? If y is 0, what's x? Four? No. So I got 0 is equal to 1 divided by x minus 4. I've got 0x minus 0, 4 times 4 is equal to 1. I got 0 is equal to 1. How did that work? Yes, 0 can be in the range because x could be either plus or minus infinity. What happens at minus infinity? 1 over infinity is what? Pretty much 0. Yeah, exactly. And 1 over plus infinity is what? Pretty much 0. Okay, so that was a trick question. But I think that covered everything. All right. So now we'll look at problem number 1, see if I can do it. Determine whether or not each relationship is a function. All right, so I got 2, 4. I got 3, 7. And I got 9, 2. For each x, I have 1 and only one y. So this is a function. Not a problem. All right, well, that's pretty simple. We'll look at number 2. I got 5, 2, 3, 3, 1, 2. Not a function. Not a function. No, that's a function. Nothing wrong with that guy, right? For every x, there's a y, but I don't have, this x doesn't have 2 different y's, and that x doesn't have 2 different y's. My x's all have a y. That's perfectly okay. Nothing wrong with 2. Try to talk myself into that. All right, number 3. 2, 5, 7, 3, 2, 1, 1, 3. Big problem. A 2 is giving me a 5, a 2 is giving me a 1. Which one is it you want me to have? So I go to the casino and I hit the jackpot. All right, I got the jackpot. Am I getting $1 million or $5 million? $5 million? All right, what a deal. But so 3 is not a function, not a function. All right, we'll look at 6. Hmm. 3, 4, 3 minus 4, minus 3 minus 4, minus 3 plus 4. Not a function. Not a function. 2 problems. First problem there. 3 can't give me plus n minus 4 both. And same thing here. 3 can't do that. So this could be a equation of a circle, right? Could be that. And there's 3 giving me a plus 4 and a minus 4. And here's a minus 3 giving me a minus 4 and a plus 4. So that's entirely possible, but a circle is not a function. A circle is a circle. Yes, not a function. Now the function of a circle is a function. So x squared plus y squared is equal to r squared. That's not a function. Well, that's not a function either, because we'd have to write it as y is equal to plus or minus square root of r squared minus x squared. And then we say, well, we have 2 functions. One function, y is equal to the square root of r squared minus x squared. So that'd be the top half of the circle. And then y is equal to minus the square root of r squared minus x squared. That'd be the bottom half of the circle. But the whole circle would not be a function. But either the top half or the bottom half could be. That would be a function. Perfectly okay. Huh. Let's see. We're supposed to find the range and domain, I suppose. Is that what we're supposed to do? But I turned the page, so I don't know. Write the range and domain. All right. Well, we're supposed to do that on the first ones, too. All right, so we'll go back and do that on the first ones. All right, so we want to know the range. 2, 4, 7. We want to know the domain, and it'd be a bracket like that. And we want to know the domain, 2, 3, 9. So the domain are the x guys and the range are the y guys. We want to know the range, 2 and 3. We want to know the domain, 1, 3, 5. We don't need a range and domain if there's no function involved, so it doesn't make any sense to even write it down. Okay, there we go. Now we answered all those questions, and we're ready to do number 15. Number 15, y is equal to 6 plus the square root of 2x minus 8. And we want to know the domain, and we want to know the range. We also want to know, is it a function? Is it a function? And we'll vote on it. How many say yes, it's a function? 1 say yes. How many say no, it's not a function? Definitely not. 1 says no. Okay, so that's 1 against 1. 1 versus 1. Okay, so the answer is yes, it definitely. There's nothing wrong with that being a function. If we were to draw it, what would it look like? Okay, at 0, well, I can't be at 0, but I could be at 4. So I would, at 4, I would be at 6, and then I would go up from there. So a function doesn't need values. Okay, so I'm not allowed to be there because I can't be 4. But I don't need any values to the negative side just to be a function. Okay, well that answers the question what the domain is, right? So the domain is x is greater than 4. Because if it's less than 4, I got a negative number there. That wouldn't be good. What's the range? Well, the range is going to be 6 is going to be less than y, which is going to be less than or equal to infinity. So this is going to grow to an infinite value as x gets bigger and bigger. But it can't be 6, because in order for it to be 6, x would have to be 4, and x can't be 4. Can x be 4? X can be 4. What is he talking about? There's nothing wrong with a 0. Yeah, there's nothing wrong with a 0. We can take the square root of 0, not a problem. X can be 4. Yeah, that's what I thought. Oh, you always have the prerogative of changing your mind, right? I mean, really. X, yeah, nothing wrong with x being 4. Ben, why didn't you tell me that? Your job. Oh, you're not sitting in the front row, though. It's the front row's job. Get hot. Front row. Okay, number 20. Given that f of x is equal to x squared minus x, find f at 6. You gotta be kidding me. Alright, so f at 6 equals 6 squared minus 6. 36 minus 6, 30. B, f at 0. Oh, I like that one better. F at 0, 0. I like ones that I can do in my head. C, f at minus 6. F at minus 6. Okay, well, that'd be minus 6 squared minus a minus 6. 42?
You're not doing number 20.
Here I am.
What book you looking at?
Oh. Here I am. I got my finger right next to it. But this is, what you're complaining about is that this is a 4. Typical back row complainer. Anyway, doesn't complain until the problem's all done.
We don't want to interrupt you or anything.
Yeah, I'm on a roll here, and the back row's not complaining. Okay, so that'd be minus 4, minus 4, minus 4. All right, now that means all these answers are wrong too. There we go. No one will ever know it unless they watch the video. What's this? 32 minus 4 minus 40? No, minus 40. 32. Okay. God, did I get lucky on that one? Yeah, I got lucky. I should have just taken out my calculator and solved it, right? That would have been better. All right, we'll move down to 25. Just to say we did. Number 25. F of x, 6x plus 8. There, do I got the right problem written down this time? Okay, so that I want f of a. F of a. Okay, there we go. 6a plus 8. I want f of 4a. 6 times 4a plus 8. 24a. 24a plus 8. F of c squared. F, what is c, by the way? F of c squared. 6c squared plus 8. No one answered me to tell me what c was. When c is lowercase, it's the speed of light. 3 times 10 to the 8th meters per second. When c is uppercase, then it's just some constant. Normally a constant of integration that you won't get to until chapter 21, but that's all right. So normally lowercase c means the speed of light. Unless you have a problem where you have 4a plus 3b plus 6c is equal to 0, and you have three equations, three unknowns, then c is just another independent variable, and it's not the speed of light. So c is the speed of light except when it's not. Okay. Is that all right? Yeah, why not? All right. Moving on to number 30. Number 30. Okay, well this looks cool. Okay, so f of t is 5 minus 2t plus t squared. And g of t is, you notice how we go in alphabetical order, A, B, C, D, F, G, notice that? They just have no appreciation at all for using any of the other alphabet. Okay, I think it has to do with the French myself, but could very well be. Okay, A. We want f of t plus g of t. All right, that's what we're going to do. So I got 2t squared minus 6t plus 9. All right, well, that was simple enough. Now I want g of t minus f of t. Okay, so the t squared term goes away. I got minus 4 minus a minus 2, so it's going to be minus 2t. I got 4 minus 5 minus 1. All right, what a bummer. I have two more to do and only enough room to write down one of them. Oh well. We want f of t times g of t. Well, I guess I can't do that in my head. And I guess I'm going to write it in alphabetical order. Okay, so I got t squared minus 2t plus 5. And then I got t squared minus 4t plus 4. T squared times t squared, t to the 4th minus 4t cubed plus 4t. So I just multiplied that guy times him, that guy times him, that guy times him. Okay, now I'm going to do the next row. That guy, this guy. And I'm going to line them up in order so that I don't get hosed in the end. Okay, so minus 2t cubed plus 8t squared, and then minus 8t. Okay, what color haven't I used yet? I haven't used that one. Then we go that guy times this guy times that guy. 5t squared minus 20t plus 20. Now I'm going to add them all together. T to the 4th, 6 minus 6t cubed plus. Oh, we're going to be challenged here, I can tell. 17t squared, 28t plus 20. So I do that right? I did. I got lucky. This is where you take yourself out of being an electronics major, you're now an accounting student. You're just accounting for things. You know, you're lining them up in pretty columns, you're adding them together, but the whole purpose is to get the right answer, is what the whole purpose is. D. I've got g of t plus h. All right, so that's going to be t plus h squared minus 4t plus h plus 4. Now what is h? I mean, you know, it comes after G, right? F, G, H, right? Well, delta H we use for a very small amount. So, and we let delta H go to 0 when we're talking about working some problem later on. So this particular problem we're seeing now with an H in it, we're going to see later in another context. So we're solving it as a function now, but later on we'll see it in a different light. All right, so now I've got t squared plus 2th plus h squared minus 4t minus 4h plus 4, and now I'm done. So I just multiplied it out. Now we're not at the point where we can do a plus b squared yet, right? But if we look in the front cover of our book, we can see that a plus b squared is number 3 in my algebraic things. It says x squared plus 2xy plus y squared. So that's how I did this. I did that by remember that identity in the front of the book. But that's different than how I did this. I could have done this too from memory, right? And then I would have got it wrong, right? I would have wrote down 2 to the 4th, and then maybe I would have gotten that term, but then this guy here added it together from memory. I probably would have messed it up and got the wrong answer and moved on. And number 32. Number 32. F of t, 8 over 6t plus 3. We want to know the domain. Don't even care about the range. All right, so what we're interested in is not dividing by 0. That's what we're interested in. So we're going to be dividing by 0 when t is equal to minus 1/2, right? So minus 1/2 is not in the domain. So now my domain is going to be minus infinity less than t less than 1/2 or 1/2 is less than t is less than plus infinity. So I can't minus 1/2. I can't be at minus 1/2 because I'm not allowed to divide by 0. Normally at that point I say until later on, but you guys wouldn't believe that, so I won't add that. And we really don't divide by 0 later on. Yeah, we do. Yeah. Well, we divided by 0 already, right? We had that in the beginning of the book, in the first chapter, I think. That if we go 0 over 0, that might be something. All right. Looking at 34, g of x, 3x minus 10, x squared plus 4. Well, can I divide by 0? No, I can't. So my domain appears to be minus infinity less than x less than plus infinity. And we can go less than or equal to if we wanted to. Being equal to infinity doesn't do much for me, but we could always say that. So there's nothing wrong with any x. Yeah. Unless, of course, I had an x where x squared was equal to minus 4. Then I couldn't do that, right? So in chapter 14, we're going to find that 2i squared is minus 4, but that's an imaginary number, and we don't have to deal with that in chapter 4 yet, so that's good. 36, and then I get to enter grades in the grade book. 36, oh, while we're doing that, we'll come up here. Yeah, that's good. 36, g of t 9 square root of 5t plus 20. And we're looking for the domain, which means we want to make sure that we're not dividing by 0, which doesn't, we can't divide, so we can't divide by 0, and we can't have the square root of a negative number. We can't have that either. Okay, so we're going to ask ourselves, 5t plus 20 is equal to 0, then t is equal to 4. So if t is greater than minus 4, I'm going to have a square root of a negative number, which is not allowed. If t is equal to negative 4, I'm going to have a 0, and I'm not allowed to go by 0. So the domain minus 4 is less than t is less than infinity, positive infinity. Okay, so now I'm okay. I'm less than 4. I'm like 3.9999999. Perfectly okay. I'm not dividing by 0. I'm not taking the square root of a negative number. And everything would be fine. Okay, questions? Thoughts? Vocabulary words. Range, domain, function, not a function. V is equal to IR. Is that a function? Is that a function? V of I is equal to IR. Is that a function?
Yeah.
V of R is equal to IR. Is that a function? No. Trick question, right? So this guy's a function, that guy's a function, that guy's not a function. What's my dependent and independent variable? I haven't told you, right? So this is Ohm's law of formula. That's fine, but it can't be a function until I tell you that I have an independent and a dependent variable. Then it can be a function. Yeah, pretty weird, huh? So, just another cross to bear, right? Yeah, just another cross to bear. We'll move down to the important things like